All right, so yeah, let's begin. Let's begin. Let's just because I made some changes in BumperCoins, some cosmetic changes to the home page and the replay. I did some basically I kind of moved the work we did on the bots for BumperCoins, not the bot but the actual project, to a different branch so that I can like work on production stuff. Like get status. Like right now I'm on prod. Get log. Should make this. Let's make this full screen. Get log. So like, so I guess these three are like kind of specific to the prod branch, or actually, yeah, get branch. Get checkout. Previous branch. So then like get log. Or wait, no, never mind. So save progress in AlphaBeta bot. After last stream, I just like kind of staged everything and just committed everything. So I just kind of saved the progress. And then the previous commit is add link to personal site on front page. So like, so this add link, this commit F5AD, if we kind of go back to like the production branch, then or sorry, then like F5AD, this add link to personal, like there are some like little kind of like CSS changes I made, so that like I noticed that in Firefox, like, well, I'm just kind of like, I'm also working on like some or I'm going to work on some personal like profile, or like some like public and private profile stuff, where you can like a publicly viewable profile where you can like see everyone's replays and stuff for registered accounts. So like the point is that like I'm making some changes right now to production. So like so how does this affect us right now for bot stuff? The point is that I'm working in a separate branch for bots, and that's why like that's it. We're working on a different branch. Oops. Yeah. So right now we're in AlphaBeta. Okay, great. So get log. So then here is like kind of like the thing, right? Let's just do that one thing, the diff stuff. Or not this one, sorry. Let's do that one. Okay, so then right now we're kind of like showing like just kind of doing a recap to see how we're kind of like using the AlphaBeta function. So like this is in BumperCoins, and then after like this brief overview, we'll switch over and do all our work in BumperCoins bot, because this is the scaffolding that we need to incorporate this function into the game. Well, no, we have to do one final CP, but anyway, so you import this function from this kind of nested repository from BumperCoins bot AlphaBeta, and then I just commented out the old stuff. So what we do is we take the game state, we convert it to the bot game state really standard, and then in doing so we're setting the is p1 turn false, we're setting it to bot true, like that's what this function does. And then to do let players select, so we're just kind of like hard coding a depth for 3, but then the to do is basically like we're letting them like do it themselves. And the bot move, so then we're just kind of like invoking this function here, giving it the game state bot converted in a format which it can use, and the depth. And then it returns what? It returns two things. The value from the perspective of the player whose turn it is, so it's kind of the opposite of connect 4. There's no negation there. And then the pair, the 0th thing is the value, and then the second argument, second return is the move to play in that position, which is 1 as bot move. And then we're just doing the conversions, and we're just kind of like giving it from the worker thread to the UI thread, and we're just posting the message back so that the player so that the bot can execute the move. So that's it. And then this whole file right here is just literally just copied it from BumperCoins bot. Right? That's it. We just have to like do all the to-dos listed. So let's kind of switch over to BumperCoins bot, and let's actually like kind of finish the to-dos and this heuristic, and then we should have a bot in progress, right? Oh, wait, no, let me kind of, no, we might have to revert this ugly file. We may have to like revert this ugly file stuff for debugging, but that's about it. Okay, great. Clear, get log. And then I also committed our changes from prior stream there, just initial, and we're working in a temp branch because, I guess temp because, I mean, just for neural, I mean, I just wanted a temp branch because I was thinking of like kind of like saving all the weights that we've done for training in AlphaBeta, I mean, in Alpha 0 to this temp branch so that I can like rebranch from a prior commit and kind of like you say we have a start fresh, reinitialize or something, like, so I can experiment in different neural net architectures. But if I experiment in different neural net architectures, I want like each experiment to like kind of have its own branch and like not like stomp on any others, and like it takes a lot of work to like get the weights, right? So like the model file. So like I don't want to like do a bunch of training and then like discard the results completely. I always want to have a copy of the results. Okay, let's look at our notes. See if I June 6th. Okay, so it does not look like I created any notes, new notes. So okay, let's just quit that. Great. Hold on, let me just drink some stuff. Okay, let's actually close some extra tabs. We don't need this infinity stuff anymore. I guess, well, I mean, should I close these 3 tabs? No, leave them open. Save and load, yeah, let's close that. So, let's close that. Let's close this. Actually, yeah, no, I do have a note. Just a to-do. Yeah, just a note to myself. Okay, let's anyways, but back to work, right? Back to work. Okay, first let's do a TSC, right? Just to make sure AlphaBeta compiles. Get log. And the same git diff, just to kind of like show this last commit, which is the summary of what we did the last few streams. Okay, so basically we have these imports. We have AlphaBeta, which uses like just the AlphaBeta helper for like negative infinity, positive infinity. Like this whole thing is basically like these 3 lines right here. This is like kind of like the entry point, like the wrapper, and that's like the initial call, so to speak, is like this right here. Like this initial call is this initial call right here, and this one we're exposing. We're exporting so that like BumperCoins can leverage the AlphaBeta function. So all we have to do is do our work here, and then we can just CP this file over, and then boom, we're done. Okay, let's get started, shall we? AlphaBeta.ts. Let's open up net.ts too as well, and let's open up mcts.ts just for good measure. Okay. So what we want to do now is generate all the, I guess, legal moves, or all the moves for all coins for current player. Look at BumperCoins, net, get policy and value. Okay. call this like get moves. Let's extract it to a function. Okay, great. So we've kind of extracted that out as a function. I mean, we could inline it, no big deal. Actually, let's actually inline everything. What's the point of defining that function, extracting if we're only going to use it here, right? So let's see how net does it. Wait, what was my comment saying? Net get policy and value. Yep, that sounds right. So let's skip this convert stuff. Okay. Convert tensor to policy, right? Okay, so what we're doing is we're kind of GameState.get coins for player GameState is P1 turn. Let's say is P1 turn is true. That means it's player one's turn. So get coins for player gives us, for true, will give us all the coins for player one. So that checks out, and then same case if it's false, then all the coins will be for player two. So now coin is basically like we're iterating over all the coins of the current player whose turn it is. Then we're okay. So now forget this nonsense. Now we're kind of like iterating over all the move directions. Get move velocity, and move velocity is exported, right? Yeah, we're exporting get move velocity from dir. That is export for move ID. Okay. So that's getting exported. But now num move dirs, we don't really have that. Let's just hard code that, or you know, for that export const num move dirs. Actually, let me just look at Scratchpad. How does Scratchpad do this? Num, or wait, no. What do we want? We want the move dirs. Exporting num move dirs. Get move velocity from move dir. So we need these two functions, I believe, num move dirs and get move velocity from move dir. So num move dirs and then get move velocity from move dir. So then we got the move ID. Moves.push move, and we're done, right? Is that it? So like for each of the coins for the player whose turn it is, we kind of generate moves in all 8 directions from move ID from 0 to 7. And then we just kind of leverage existing trig function, move velocity from move dir. We build the move, and then we push the move, right? Or no, convert. tensor to policy. Yeah, I was just looking for this -1 in the actual trig function. Okay, good. That's it. Okay, so I think that is the to-do right there. Okay. So that's that. What else? So that's so now for each of the moves, we just kind of unroll it. We just recursively, so then we get the child move, and we kind of do the recursion, but then we have to flip to -1, and then these signs and swaps are just like we talked about that last stream. I convinced myself of the correctness. And then like we kind of are getting the max value. So like whenever we beat it or like equal it, then we just kind of say that this is the most promising move. This is the best move we've seen so far. And then we get the max value, we stored that. And then of course alpha always maxes over because alpha is like kind of like the best that this player has done so far. And then the moment that we're outside the range that like beta allows us to be, because beta is again like the best we're allowed to from, which is like kind of like the inverse, like the best the other guy can kind of do and like from our ancestors. So like if the other player can kind of force a score through some different line that like beats what we have done from this one, then it doesn't make any sense like further in exploring here, because like our opponent can just never let us enter this position to begin with, because they'll always use the beta path, which is the best for them. So that's kind of like the logic behind AlphaBeta printing. And then there's an empty space here. Let's just delete that. Or empty line. And then we just kind of return the best value and best move that we're kind of like doing the max and argmax over. So okay, that seems about right. So now all we need, in theory, this should be correct. So all we need now is a heuristic. That's it. And then we're kind of done with AlphaBeta. Okay. Let's bring out our trusty old whiteboard, right? Time for a whiteboard. Okay. So let's go down. So we have GS, our game state, and what we want is our heuristic. And then we want a value, right? So like, how does a neural network do it, right? Like a neural network, kind of like convolutional network, it's like, or like, in general, it's like we want some features and we want some like kind of weighted, some linear combination of them, like, and like kind of like, maybe like in a CNN, like, it's like these features are kind of like automatically kind of just kind of like magically through gradient descent, like kind of these filters just like filter out like what needs to be filtered out. Or what am I saying? Not filtered. These filters kind of extract the features very dynamically. There's lots of flexibility. Like it's like we're not hard coding features from a net. We're like training it to kind of like learn what to extract in general. Or like, never mind. I already talked about the math. Actually, yeah, there's those videos I recommended in the very first lecture, like a playlist. In fact, I believe the author added some more videos about some of the newer stuff that everyone's talking about these days, which I don't really know at all or really care for, to be honest. Maybe I should. But anyways, the point is that like we're just kind of treating this as a very simplified model. We're just kind of hard coding some stuff. And I did this a few years ago, and that produced the bot that I kind of had here, right? Like this bot that I had here, this is an AlphaBeta bot, or a bot min max, I see. And actually one thing is bugging me, this 1200 and this question mark, I should just delete them entirely. Okay, I'll just note that, never mind. Many months ago, we really created depth 3, so that was like 3 years ago. Manually, depth 3, that's what I'm using, depth 3. I manually assign weights to features. Coin health king health, octal distance to enemy king. Okay, so like we can just kind of consider that too. So like we need some like a feature, like feature 1 of like the GS, or like the feature not 1. We can make the feature I, weight I, and then we just sum over I. So like we need some features. So the first feature that I used was like the overall coin health, king health. Let's just say like 1, like coin health, health 2, or I guess like coin health is like both king and non-king. King health, non-king health, then 3, what do you need? The octal distance to enemy king. King. And let's just actually negate this. So then the convention is that like if these will return positive, like positive equals good for current player, because the current player's king has is healthy, that's great. And if the non-kings, we can like maybe like call them like average or something. Average, I don't know, I'm just like kind of making things up. Average, then that can be like good for the current king. I don't remember what I did last time, those years ago. And then octal distance is like, there's a bit of an inverse. That's why I flipped it, because like the closer we are to enemy king, the better. And then the further we are, the worse. And should this be for like all the coins or just like our non-king coins? I think all the coins, because like even if our king's close to its king, like okay, so this is like the function. And like of course we have to subtract it for like the like if it's our king's health, like you have to do like minus opponent's king, like op.health, health, and like minus, and then the same thing from the respective of these. So one thing so first of all, a good starting point would be like functions that like kind of give you feature for the perspective of the like just an extractor, right? Like extracts it, like gets these numbers 1, 2, 3 for a particular player. So let's just take 1 for example, right? Well, let's just consider 1 king health. So we need like cur, or actually let's call this P1, like P1 king dot health, right? Minus P2, or sorry, like P pcur dot health dot king dot or you get the point. Like there's a subtraction too. That's it. So like what we need is we need these three things. So let's say we have a class called feature. Like a class like feature. So what does it have? So if it'll first need like a weight. Or actually no, so we have a class feature. How do we use it, right? We're going to instantiate these three features, call them on GameState, and just kind of sum them up. So then the weight will be kind of built into that. Drink some water. Whoa. So the class feature will have weight, and then it will have a like an extraction of the game state of a GS. It'll have like a get get what? A get score, get contribution, get evaluation. What should we call this? Yeah, just like get score. Eval game state. And like a perspective Boolean. Perspective, and then that will be like, let's like call this function E. That would be like W times like E of like for P1, and like same thing minus E, and then like for the swapped. Okay, so let's kind of do that, right? Let's just copy this class definition. Let's put it in the bottom. And then extract score GS game state. game state, and then what? Game state, and then 4p1 billion. Billion. Or sorry, so extract score is a, how do we do a type signature? I mean, how do we do a function, a lambda? Like, how do we define, what's the type for function again? What do you have to work with? I know I did this somewhere. Oh, symmetries, right? Let's call this final thing get. Instead of Q score, it'll be get score return this dot weight times something else. So then it'll be extract score function, which takes in the game state and like the perspective we want, and then it returns a number. Like that. So the constructor kind of looks like very kind of like, so like, I mean, paren, like paren, and then arrow, return type. So constructor, paren, arrow, return type, number. Okay, great. Okay, that looks good. Features. Or let's not export it. So we have the features. So in the heuristic, or sorry, we have to actually define the get score, right? But anyways, but in the heuristic function, what we need is let sum number equals sum number, get it? Return sum for let feature of, I almost did the Java colon features sum plus equals. So everything's kind of like well organized and like very object oriented. Very nicely delineated structures. Okay, so then sum would be feature dot get. Oh wait, get score needs to take in the game state, obviously. It's like a one-to-one mapping between this and like the whiteboard, but then gs dot is p1 turn, right? Function game state, and then game state dot is p1 turn. Yeah, I can see it right here. Turn minus. Now, is minus okay? Like minus kind of like means that like we're kind of like, how do we say this? Like minus it is basically like assuming that like there's like a +1 weight here and like a -1 for this guy. But I mean, we know that in reality, like the weights might be different. Like some players are very kind of optimistic. Like there's like in chess, like there's like this kind of like notion that people get that their position from their perspective is like better than it really is. Like they tend to overestimate their position, underestimate their opponents. Like so oftentimes, like for me, like I'm thinking I'm doing really well, and I allow some counterplay, and then I just get destroyed because I'm like too overconfident, and then like wait, I didn't see that because like it's like my opponent can make moves too, right? But like I don't know, it's kind of like when we're doing like this whole thing, like this whole approach, kind of like even like with the neural net stuff, like our turn-based variant, in all the approaches, when we're building a search tree, we're assuming that we get to move first and then our opponent gets to move, and like that. Like we want to kind of get our moves on the board, like get our moves in our mind and like kind of make some progress where we're doing something first, which may not hold true in like actuality. This is just an abstraction simplification. But anyways, yeah, this is all just very simplified, very like, you know, classical min-max stuff. Like it's not like it's not like very how do I say this, like very very I mean, I don't know, it's not very realistic, maybe, I don't know, it's not very faithful to reality. I'm like that. Make sure this compiles before implementing these features. Okay, and we have some errors. Okay, 68 and 73 are the offending ones. Okay, so I think that's this dot weight. Okay, great. Oh, this dot, I see. Great, everything is good. Let's just quickly add our stager changes. So this stuff compiles. All we need to do now is just implement these feature functions. So let king health feature or I think I did the other way. Function king health, not function. Actually, no, let king health feature. So yeah, just new feature like that. So what should the weight be? Let's just set the weight to like, I don't know, like 5. Let me see how symmetry does it again. Okay. Instead of doing that, match it with the brag. Okay, so we just have to fill in this function. King health. If coin dot, what do you call that? Coin dot, like what's the coin P1 thing again? Is P1. Coin dot is P1. Is P1 equals 4P1. Actually, let's, and then the coin is king. Actually, let's put this one first. Like, let's put this. Let's put the king one first, because that's that filters out like half that filters out like of 6 coins, only like 2/6, only 1/3 of them are king, so it filters out 2/3. Whereas this filter only filters out half, so like would short circuit and exit out of this if more often. Coin dot doesn't really matter. Dot is, so the coin is king, and the coin and the coin's p. So like if the coin, let's say the 4P1 is true, and it is, let's say the 4P1 is true, then if the coin that is P1 is 4P1, and then if it's false, then for players 2, false is false, so that would be true. And then if it's, yeah, okay, so that makes sense. The coin is P1, and it's for alignment, it aligns with this. Then king health equals coin dot health. Oh, that's a fixed point. Fixed point to number. Okay, great. Let's just make sure this compiles. Okay, I see. Very, very trivial. Okay. Status. Get all. Status. Great. Okay. So we added a, so then what we do, we kind of generate the moves. And then for the heuristic, we're just summing or like getting the score for everything. And then we kind of like need a feature. So then when we define feature. So this is basically kind of like king health feature. Now we need like some, so that's like king health. Then we can like kind of like do something with the average of the non-king healths. And then like I mean, technically average, maybe not. We can just sum up everything and like let the weights do it. I don't know. Because again, the convolutional neural net, like it's more fine-tuned, or it offers us more kind of combinations. Like it's not just the king health, but what's the word? Spatial relation between like, because like if one of our coins is really close to the enemy's king, and like we're about to like hit the enemy king and like really knock it off, then we want this knocker, like the striker, to like have high health. So like that coin is like more important. And like a defender around us might also have like higher importance. Like its weight should like be a bit more, but that's like kind of like dynamic. That's like a dynamic feature. It's not like hard, like very naive hard code, like simplified and just all coins are created equal. Like it's more a nuance, like more nuanced than that. But anyways, now actually let's just have an average. I don't even care. Actually no, let's just sum them up. Yeah, but no, because what if like no, average is a bad idea. I think we should sum them all up. Because like what if all our coins are dead? Except one. And that one has full health. Then like the average would still be really high. Okay, technically we could consider them 0 if they're dead, but no, let's just sum them up. Yeah, that's a very simple feature. Because again, this doesn't have to be like idealistic, like the best. This just has to like just like ship something, you know? Okay, let's just call this I'm gonna copy this whole thing that we did there. Non-king healths feature. Some healths. Return some health. So now for the coin, if the coin isn't a king, now let's just move this thing there. Like that. So if the coin is for this player that we're like for it. So 4 basically is like kind of like the positive perspective. It's such that like, or it's like we're doing it like this function king health is like for the players, like who's king, like which player's king, and that's what this parameter specifies. And we want it such that the extraction function will return positive if it's good for that player that's specified here. So like this argument in the extractor score function, this argument, like let's say that this function returns a number, right? And I mean a positive number. So like if it's positive, that means it's good for this player. Like that's kind of how the perspectives work. So that's why when we're doing get score, we're kind of like getting the score for like what's good for me is positive, and then what's good for my opponent by flipping this gets negated, and then we kind of that's why you have like kind of like a +1 weight here and a -1 and negative to negate what's good for them. So like what's good for me, like the feature for me, it's like dual, like the duality. It's like kind of like what's bad for them and good for them is like good for them and bad for us, like and vice like that, right? So that's where the negative sign. And then we're assuming that again, I talked about the weights are very simplified. Then we multiply them the difference by the weight. So again, it's very kind of like, it's very reduction. It reduces things a lot. It's not very fine-tuned at all. So sum health and then plus equals the so the coin dot is for, so that if the coin we kind of filter out half, and then this one kind of does bear us a non-king coin. Okay, like that. Then the coin health, what we're doing is we're just going to sum them and then we return that. Okay, great. Let's just see that that compiles or status. Okay, good. Let's just do the compile check. Good, it compiles. Okay, so now we need like one last, or well, we can start off with a because again, like what are my features here? Coin health, king health. Again, like this seems a bit redundant. So yeah, an octal distance to enemy king. Again, it's a heuristic. Oh yeah, we should give it weights too, right? Or a king health feature. Well, what's the weight here? So let's just make this less than 5. Let's just make this like 1. Because let's just like say that the king's health is very important compared to this. I mean, there could be a case for like normalizing these things. I don't know. The feature extractor can return from like get score could return from 0 to 1 maybe, or sorry, negative, or negative 1 to 1, like a 10H value range. Well, those are asymptotes, but, or never mind. Actually, no, there's no need for normalization or anything fancy. Like, again, like the negamax stuff only depends on like 0 is draw and then positive is like good and like negative is, it's just like it's just the sign that matters. Like the magnitudes, it's more of like the comparison, right? Like we can scale different vectors, but it's more of how they are relative to each other. Like it's more sign based and like relative. Like a greater number minus a smaller number will give us a positive number. So it's like that kind of thinking. Like there's no like need for like normalization to like do some like, you know, like a batch normal. Like it's like there's no really, I see no point in that. Like sure, if we're training a net, then like yes, I know those layers like have some help some like backpropping, like they do help. Like we don't need that. That's like orthot. That's unrelated to this stuff. Actually, one idea that we could, yeah, actually, let me just do that. I just realized something. Here, like, allow players to manually set weights from drop down from some menu. Like right here, at very least, select which bot to play in case, or yeah, select which bot to play with, and then also they can select like, also select some params for the bot, like for alpha 0, or actually for alpha, they both start with alpha beta, the search depth and weights of features, and for alpha 0, just like connect 4, C4, let them toggle the num mcts simulations. Okay, great. Let's just delete and then oh, well, this one is very unimportant. I'll remember it. Okay, great. Oh wait, hang on, I hear something outside. I'll be right back. Okay, what should we call this feature? First things first, copy it, So what should we call this last feature? Octile or octile distance to enemy king. What do I call it here? -1. Octile distance to enemy king. I actually want to comment here. Comment in our feature. Convention is function returns positive, meaning this function returns positive if the game state respect the game state is good for P1. State is good in terms of this feature. So basically this function is like the heart of the feature, which is the convention. That's why like this one might be a bit different. Distance to king feature. I'll bring that back. Let like some dists be 0. And we're going to return -1 times some dists. Why -1? Because okay, dist to king, like first of all, like we do it for us, right? So this first thing should be good for us if what? If our distances are small, right? If we are close to the king, if we're close to their king, then actually not positive, but returns returns larger values if the game state is good for P1 for this feature. Because like this feature will always return negative no matter what. It's just the relative differences in the negative that matter. So that's why I like larger value. Or return values. Turns larger values, the greater the game state is for the player for P1 or specified by for P1. Yeah, because not just the signs actually. This is not some like 10H output from -1 to 1 where it's like 0 draw. Like it's more of like the relative differences in numbers. So I guess like that's a more that's like kind of a more just a more comprehensive, or just like a it's just a more precise, I guess, or I don't know. Okay, so sum of distances. So first loop, what we should do is we should actually like get let enemy king coin to undefined. So if the coin is not for us, and the coin is the king, then the enemy king equals the coin. Enemy king equals undefined. Or I guess not enemy king, or never mind. Just return 0. This should never happen. Okay, so what is this then? For coin of GameState.coins. So for the coin of GameState.coins, if the coin.p1, so let's just say p1 is true. So for the coins, if the coin.isp1 is not equal to 4p1, so that means it's an enemy coin. Because if this is false, that means that the coin p1 must be equal to false. If it's not our coin and it's a king coin, then enemy king equals coin. Okay, great. And then let's also have like let our coins coin. I mean, I guess we have a filter method like get coins for this player, I guess, which also does it for us. But we could do it in one loop. We're basically re-implementing that. Our coins. I don't want to like kind of have 2 iterations over it. Just loop it once. Our coins coin.isp1 equals 4p1. So like if this is true and then the coins.isp1 is true, then that's great. Then our coins dot push coin, right? Okay, great. So then what? Okay, so we have to just now like kind of do stuff here. So then before let our coin of our coins, we want to kind of like compute the we want to like get the octal distance between our coin and the enemy king. How do I do that again? I know square root of 2 is involved, but I kind of forgot the A star search, consistent heuristics. Some guarantees proof by contradiction. Square root of 2. Forget this JS specifier, just get octal distance. Yeah, there's Manhattan distance, but like the coin, the way, I don't know. Yes, admissible. Yeah, admissible. If it's always bound within the actual cost. Yeah, because we do have like it's not just like north, south, east, west, not 4, but we have diagonal too. What? If, here we compute number of steps if you can't take diagonals. So that's just like 1 times like just dx plus dy, right? Just simple Manhattan stuff. Just that's like what it was be if we were to go here, here. If we were to go like here and here, then that's kind of like what you would be taking. Then subtract the steps you save. So like basically like you have like this and like this, and you if you do this minus that, then that's like the savings, which you subtract from this. So like what is the savings? How many diagonal steps? Min of dx dy, which is this one. Diagonal. So if this is like 1 and like 1, 2, 3, 4, then like we could take 1 step diagonal here and then 3 right there. Okay, I see. Yeah, that makes sense. Okay, yeah, I got it. So like min of that. So like so that's how many diagonal, because like yeah, because it's like you have to like go diagonally to consume all of it, and then the remaining one is just we just kind of go like we like instead of like going 1 and then 4 here, we can go diagonally 1 this way, downwards, down diag, or like backslash for 1 and then 3, right? So amount of steps that we save. So that's how many diagonal. Then each of these steps, again, because like if you have like 1, 1, and then like how what's the like the length? 1, 1 root 2, right? Because Pythag, like 1 squared, that's where square root of 2 comes from. So then that's so that's a d2, but then it saves you instead of like if you go here, which is root 2, but then you save like this one and this one. Okay, that is a yes. This is a very nice yeah. This is pretty cool. It's the heuristic. Okay, good. That's what I was looking for. It's not gonna be equal to 0. I'm gonna eventually change that, but I just want to write the formula first. So math.square root of 2, and then, so how does that work in like 1, and then like if you have like, so you have like 1, okay, so you have like, wait, like 1, then 1, 2, 3, let's say, then how much do you save? Well, one route is you take 1, 2, 3, 4, like that, but then, or what's the savings? Like you have, like instead of going 1 and then 1, 2, 3, you can just go 1 diag and then 1, 2. So then you have the diag. I don't want to look at the front, I want to rederive it. So you have like that one, which is like the min of those dx and dy, and that gives you like the amount of diags. So that's the min of them, and then you have to kind of like, so you have to kind of add up that again, and then wait, this feels circular. Okay, so then you have like, so how much are we saving again? So square root of 2 times the min of that, right? That has to be done. Square root of 2 times the min of that. Square root of 2 times the min of, so let's make it 1 and 3. Like, let's just do like, kind of like, oh, don't look at that. Let's just say that we're kind of like going 1, 2. Like here and here. Like we could do like 1, and that would be like 1 and 3. But then instead what we can do is like here, square root of 2, and then like 2. So how much do we save? Well, we save the max. So we save this plus this. Or how much do we save then? So everything here kind of cancels out, is the same, but then what we get for our savings is like, is this thing right here. So then like everything here is the same, so we don't have to think about that. It's just like, let's just make it like if this were 2, like 1. Actually, we can use this grid here. If we have like the point here, it's like 1, 2, and like 1, 2, 3, 4, 5 here. Then we could like kind of go down here and down there versus going here and here. So this stuff is the same, but the savings we get here are like, rather than like doing 2 and then doing 2 here, we can just do a 2 root 2. So the amount we saved is like this, the min, minus like, let's call this like equals m, the min. So the amount we saved is like this plus this, that's 2m minus min root 2, and then we factor out the m. Wait, what? Wait, this doesn't look correct. Yeah, we plug it in. So then, so d2 is square root of 2 minus 2 times d, which is 1. because again, 1 and root 2 are geometrically like, it's just pure distance based. It's not like certain distances cost us more. Like, that's not true. So everything's uniform. So square root of 2 minus 2 times 1. So square root of 2 minus 2. Square root of 2 minus 2. Is that what I have? No, I have it the other way. I have it reversed. Oh, because I have a negative sign right here. Okay, yeah, that's fair enough. Okay, I think the signs are, I'm just going to use their formula. So then dx plus dy plus yeah, I'm not having a minus. I'm switching this to a plus and then doing that. So dx plus dy plus square root of 2 minus 2 times math.min dx dy. And again, I can't really like factor them out because like this and this we can't really factor out, even though it's like because of the min. Okay, yeah, perfect. So now dx is what? Fixed point dot two number of what? Because again, like we want this heuristic to be really fast. We don't want to like actually do a square root thing because like we don't want to actually compute the true distance. You want to use a heuristic because like it's exponential, right? Depth 3 is like 3 to the power of, or 24 cubed, or 24d, where d is the depth and 24 is the branching factor. Fixed point dot two number enemy king dot x minus, I have to absolute value it too. Okay, I think that's correct. Absolute value of the whatever. Absolute value, you can swap these two, it makes no difference. So dx. So dx, we take the enemy king dot x fixed point, so we convert it to a number, and then we subtract fixed point dot two number of r coin dot x, so enemy dot x minus r dot x absolute value, then enemy dot x, and then r dot or enemy dot y, r dot y is for dy, and then we just do sum dists. And then we return -1 because like if the sum dist is super small, that means we're really close to the king. And then that's really good for us. So we're just negating that because that's lesser, because like if we were further away, then that means that like we're it's an inverse relationship. Like this dist is inversely related with the how good it is for the player one. Because if this sum dists are very small, that means hey, we're very close to the enemy, so it's like great. So it's like inverse. That's why there's a -1 to account for that. Because like when we're actually doing the subtraction and the actual get score, we're doing it like where we're like this subtraction, then like because of the subtraction where it's like what's good for us, and then we have kind of like doing that. So it's like, anyways, that's the whole reason for that. So that's why I didn't say it's the sign. It's this convention right here. The greater it is, it's more of like it's not just the value we return, but it's more how when we subtract it, it's more of like the comparison. When we're doing alpha and beta, like alpha, beta, min-max, it's like the values we're getting, we're like maxing over them. So it's fundamentally a comparison-based thing, not like an absolute value thing. It's not the values themselves, but the relationship between different scores that matters. Okay, so we have this feature. I think that looks good. Again, lots of code, so like hopefully this works. Hopefully well-reasoned code. And again, I have done this and I got like the results I showed like here. So like the bots do somewhat do something that it's like they're still terrible, but like they're better than no bots at all. Actually, I'm not sure about that. Okay, so we have our feature, our 3 features, and I think are we good to go? Might be. Status. Or actually, make sure to compose before adding it. Oh, we have to import coin. Okay, great. So now that we have this, let's actually go back to our BumperCoins. Status. Let's just do a bit of a CP. So we're CPing the sibling directory alpha BumperCoins bot AlphaBeta TS and different status. Get diff. Yeah, we're just kind of like adding a feature, and yeah, it's just the work we just did. Okay. Let's see what our result is then. What is our result after implementing this? Like we did a bunch of code for AlphaBeta. Now let's see if it gives us anything meaningful. Okay. Let's just let it move for a while. So far it seems to understand distance is good, but when's it gonna actually hit our health or hit our enemy's health? Why is it not striking? Okay, okay, let's kind of look at our I guess that's why normalizing these could make sense, because like the distance will be pretty large in the order of like double digits, like 20 or whatever, right? Because like the horizontal thing. So that's why like I think that I guess some normalization might make sense where like we could normalize where the max possible distance, which is like what's the max distance, right? The max distance is like between here and here. So it's like, what is this? This is like 15, 20, and like the high pot. Like we could just normalize them over that. I mean, we could do that, or what we can do is just kind of increase this to like maybe like 10, and this to like 50 or something. Actually, no. Actually, let's just try to let's try to add some. So this one is kind of already normalized-ish. And like this one, let's see, sum health. So then this one, what we can do is like sum health. We can just do like this. We can just do divided by 3 because they're 3 coins. Actually, no. Yeah, divide by 3. Actually, no, we divide by 2 because there's 1 king and 2 non-kings. Actually, let's just kind of have a constant here, like const hypot equals math dot square root of 15 squared plus 20 squared. So that's the hypot. Let's just do this divided by hypot. Plus denom. So the idea here is like, means we're dividing by the hypot and by the constant 3. Divide by hypot because so that's the max octal dist present on the board. Actually, no. The max octal distance will be this. It'll be like 15, and it won't be like directly, right? It would actually be a bit more. It would be 15 root 2, and then plus 5. Sorry, yeah, no, never mind. Hypot octalized. So 15. Oops. 15 times 15 times math square root of 2 plus 5. Because again, the idea is that you would kind of like take like go down here, and like each step is root 2. You'd take like 15 of these, then you take 5 to hit from like bottom left or top left, bottom right. That's the max kind of thing. It's like some. The hypot is that's the max octal present on the board, ensuring each sum dist plus equals sum dist contribution and divide by 3 because that's the number of Actually, no, because some coins could be deleted, right? Wait, hold on. If, like, instead of 3 coins, we have, like, 1 of them, then the distance to king, like, how should that reflect? Okay, instead of dividing by 3, let's divide by hyponormalized. And let's take that whole thing. Wait, what? Let's take this whole thing here, right? Let's divide this instead of by 3. Divide by our coins.length. And for here, we're dividing by 2. We're not dividing by number of coins we have, because if we have 2 coins, great, we would have done 2 contributions. But if you only have 1 coin or 0, because all our coins are dead, we're just the king, then we'd return 0. So this is more like cumulative, or like the averaged out takes into account dead coins, because dead coins are bad. Because that means like we'd have less contributions. But then here it's like, I'll have to do some more thinking. Wait, no, I have to do some more thinking. Let's think. Distance to king. Distance to king. Okay, I have an idea. Okay. So we can do the thing in the contribution level itself, right? Okay, yeah, I got it. I have some notion of how to do this then. Okay, so then in our contribution, right, what we're doing here is like, sorry, this. Like that. Then let contribution number equals to the hypo-octalized octalized, right? So the hypo-octalized. So like we know this has to be like, it's like, so we're kind of like getting the complement of that, right? Minus like octal distance. So this is a measure of like how close we are, or how, what am I saying? No, sorry, wait, hold on. Let's just actually draw it out, right? Wow, this bot is just killing. It's imploding. Let's just close it. I don't want to look at that. It just disgusts me. So let's just say that like we're like that's the king coin, and we have, or let's make it kind of dark, and we have like one coin here, and like one coin here, and that's it. In our other, like we only have 2 coins, right? So we have like this distance here, and this distance here. So like, how do we actually like kind of contribute them? So first of all, like the more distances, like the more kind of contributions we have, each contribution, like the more coins we have, like the more like that's good. Like what I'm saying is like if this were to not exist, like if this coin were dead, then this contribution distance that we get like should be less than like what we get from here, right? So like we do want to sum over the coins. So that's like this contribution should be positive, right? That's like one thing. Cause like yes, even if we do add this distance, the average distance would be something between this and this. Like the average would be something like that, right? But like it's like we can like now that we have this, like that's great. Like that we can only do better. So then that's one thing. One, we want to sum them. And 2, this contribution from this coin is much greater than this coin. So there is some notion of like inversing at the contribution level, right? So that's why what we can do is we can like consider like the normalized, the hypot normalized. Again, like this is not like, again, it is like that and that, but let's pretend we're working without octal bullshit. So like we can kind of like get this one, and we can consider this distance here, and then we can kind of like get the complement score. Or wait, no. What can we do? We can get the complement. Like okay, let's just say that like sorry. Let's say that like this distance is like D and this one is like 1, 2, 3, 4, 5D. Then like this one I want to say is worth like 5 times more as that one, right? So like this contribution should be like worth more. So like we want to somehow flip the distance in the denominator, right? Just 1 over D, maybe? 1 divided by the octal distance? And then, Then how do we take into account like the hypot then to normalize it? Let's consider from here and here, right? If we do 1 divided by that one, we'd get a really small number. But then if we're super close and we do 1 divided by that, that can blow up really kind of badly. No, 1 dividing by something is a really dangerous thing. Like 1 contribution scale inverse with distance and 2 like normalizations And doing 1 divided by distance is terrible because we're super close. This term will blow up really big, right? That's not good. So let's say you get a normalized distance like this divided by that. Again, this could still blow up, right? Just stick in a d plus 1 term, like rather than 1 over d, like do like 1 over d plus 1 kind of thing. So that like this way, like it's like distance can never be, and then we can like do like d norm or something, the normalized distance. So that way, this will stop, this extra like term right here will stop it from blowing up. So let's say this is 1 unit and like this is 5. Then 1 over like, and then like this whole thing right here is like, I don't know, like 30 or something. Or what's 15 squared? Squared plus 20 squared, 625. Really? 25? Wait, what? Okay, fine. So 1 plus 1 over 25 versus 1 plus 1 plus, no, so 1 over 1 plus 5 over 25. So 1 over 25 is what, like 0.04? 0.04 plus 1 equals 1.04. 1 divided by 0.04. 0.96, okay. 0.96. 0.96. And then 5 divided by 25 is what? 1/5, so 0.2. .833. See, I don't like this. Because if you look at like this one gives you 0.96 and this one gives you 0.833, like that doesn't feel right. Like this one is overvalued, I feel, relative to this one. So this inverse thing I feel needs to be done, but like this thing doesn't feel right. So one thing we can do is like kind of have some radius around the king where like that will kind of get clamped to a radius. Like if we're within some like hitting distance, again, we're not even considering energy. Like if we're within some distance, then we can kind of like clamp it to like to 1 or something. Like if we're within range of 1, then we get, so we can do 1 over d or normalized distance. Yeah, we can just forget the hypothesis. We can just like do 1 over d, but then like d equals to like math dot max of like 1 and d. So that if d goes less than 1 and becomes like super small, then we just clamp it to 1. Okay, yeah, this seems very kind of iffy, but yeah, let's kind of like do that. What about the high pot though? Let octile dist normalized. Octalized. So normalized means it's between 0 and 1. Okay. Then what about the stuff there? Plus equals the contribution. So this is like the naive version. Like that's the naive version. But the problem is like this could blow up. So instead we do dot max. So then here 1 unit would become like pre-compute these values. So here we can take this and then we can kind of clamp it down. So it's like 1. So like if it's too small to stop it from blowing up, we can just like say like if it's too tiny, we'll treat it as being 1 unit away. And then we normalize it. And then what we want to do is we want to let yeah, that's it. Actually, octal just clamped. Yeah, I don't want it to blow up. So this one, like the lowest it can get is 1. And we like normalize that. So this could be very small, which is fine. But it's just not going to exceed, it's not going to exceed 1 ever, so that's good. So this number, like the lowest this number, like we're kind of like doing this, like, let's call this clamped normalized. Just like that. So let's analyze this. So octal distance is like the octal distance, but then it could be really tiny. So then we'll just like say like, hey, like we're going to floor it at 1. So like it can't really dip below 1 because if it does, then we max it against 1. So that's the lowest this can get. So this can be between like 1 and let's say like between 1 and this number here. That's its range. So in this fraction here could be between 1 over this and 1. So it's basically, it's not going to exceed 1. That's the lesson we get. Then we add it to sum. Okay, great. I think that looks good. or looks promising. Get status. See if it compiles. Yep, get add all. Get status. Then let's cd into that and cp over the newest version of it. Get diff. So as we can see here, do we have all this new stuff we did just now? I have to use the bathroom. Yeah, we have all this clamp normalized stuff. Great. So now let's just run it and see if anything changes. And of course, we have to tune the weights and just kind of play around with that and debug it. Okay, now let's see how the bot does it. Okay, so it's moving a coin like it did last time. It's getting closer. Good, it wants to be close. Okay, now it's going for hits. Oh, it's not going for hits? Okay, so this looks terrible. Let's unminify that. Okay, it's kind of lagging, but anyways, she'll work on min on a state valuation heuristic status. Get log. Copy. Status. Okay. So now this should revert it. And now let's see how the bot runs. Or I mean, let's see how the debugger debugs. For a heuristic. Okay. So let's take this and let's move it here. I'm gonna use the restroom. I'll be right back. All right, where were we? I'll put this, oops. Let's kind of take this. Let's just, let's put this in the bottom actually again. What? Oh, those were player 1 equals true. I see. Well, we want player 1 equals... Oh, wait. We want player 1 equals false. Let's just keep playing. Those player 1 turn is true. I want it to be false. Okay, you know what? He wants it to be true. Okay, fine. I'll comply. Hey, it's running away. Now what's it gonna do? What is this supposed to do? What? So it's for P1 equals true. So it's how close my coins orange are to his king. So it's like one is very close, one's middle, and one's kind of far. Right? Okay. So dx is 1.9 and dy is 9.66. So in clamped, I mean, doesn't really change much. So clamped is same thing. See, octal distance, so what's dx and dy again? Dx is like around 2 and then about 10. So 10 and 2 is like 12. And then 10.4. Okay, yeah, that's reasonable. That's between like 10 and 2. Or what am I saying? 10 and 10 plus 2. So octal distance makes sense. And what's normalized? What's hypot norm again? What's a fraction we got? Maybe we should normalize it first and then clamp. So now this number here, which is our denom, will be at least 1. So that means that when we're dividing, we're not going to blow up. Wait, no, wrong. So octal dist, and then octal dist normalizes, acts on octal dist, and then like this acts on that. Octal dist, and octal dist normalized clamped, acts on octal dist normalized. We should do this. We should divide by 3 actually, because 3 coins, right? Same idea for 2, and then just divided by 1. Even if 1 dead. So dead coins. So it's like averaging. So it's like we're averaging for dist dead coins giving contrib of 0. Divided by 2 non-king coins. If we're averaging helps if one is dead contrib 0. Okay, great. And then kings can never be dead. They can only be checkmated, never captured. Because again, if there is no king, then game would be over to begin with, right? Okay, this seems a bit more reasonable to me. So now we're kind of like normalizing, so it's like this would only return like at max 1. So then at worst case here, we'd return like 1 and -1. Like the highest we can get is like 2, I guess, I suppose, maybe. What are the weights again? So the feature is 1, okay. 1, that's standard, sure. Non-coin health's 1. Okay, so everything is just 1 equal. But in king health, boom, 5. It's really important. The differences in health. Okay, so then, yeah, let's see how this goes. Compiles. It's going away. What? And now it's going towards the king. I guess in the start, the depth can't really like do much. Is it afraid of its own health? What is it even doing? What is this? This zigzag. It's P1 true, so us to him. $13. So we have octile dist of like 16. Okay. We normalize it. So now it's like 63. Oh, I think I see. We can't just max it with 1. Because normalized will always be less than 1, so this whole thing is stupid then. Right. Status. Oh, I even staged it. I shouldn't have done that. Oops. Wait, no, wait. Wait, no, but restore would restore to 2 further away. Never mind. Okay. We clamp it. So 1 divided by dist, but the issue here is we're not using hyperoctalized, right? So if we're within 1 radius, that means we get 1 point for it. Then if we're like within like radius 2 or something, then it's like, or like five times away, then we get like 1/5 and so forth. So I guess we're never going to reuse this hyperoctalized to begin with. I guess the normalization's kind of like baked in here, like the max that we clamp it to is 1 to avoid this from blowing up. So round up to 1 if it's fractional. I mean, if it's only fraction. Let's uncheck this. Oh, it's still. Okay. Okay, it's moving towards my coin. Good, it's not zigzagging. Good. Good. Come on. Start to hit. 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 Yes. The bot is attacking me. Okay, move close. Then hit. Okay, I'll hit back. Now what will you do? Will you retreat? Will you try to go away? Or will you, yep, you're still going. Come on, hit. You can do it. Okay, good. Alright, now let's see. Now let me play an actual game. Oh, you're running away. You're afraid of me? Trying to slip around? Okay, well, it's my turn to attack. Let's see if you're defending. If you can defend. Oh, yes, you're going away. Alright, fine, bot. Come closer for me. I have a little gift for you. Oh, you're hitting me back. Okay. Playing a little bit of a merry-go-round, I see. Alright, I'm coming for you. Interception. Very nice. Let's see how many ticks we're taking. Sorry about that. Console.log. 11 ticks. Okay, great. Yeah, that's pretty feasible. Yeah, the bot is running away from me. Okay, good. I like how this is just like emergent property. We just give the heuristic, and from that it just kind of works out of the box. It's kind of satisfying. Let me just. This is much more fun to play with than my AlphaBeta bot. Oh, it's really okay. It realizes it's okay, fine. King we king. Let's do it. Come here. Let me just save up some energy, and then it'll run away. But what it doesn't realize is I can come in from here. Okay, that was actually satisfying. All right, get status, get log, get commit, or sorry, get status, get add all status, copy over latest, copy over initial alpha beta bot status. Okay, great. Okay, yeah, I think this is actually like ready to push. So now what I'm thinking here is like I'm gonna have some toggle where you can like choose which bot to play, like alpha 0 or alpha beta, and then you can specify some parameters. So let's just like work on the UI cosmetic stuff next stream, where like you can let the player like toggle their own settings and stuff. I think the constants we chose like 511, where 5 is for the feature of the king health, and then 11 are for the remaining features. I think these are pretty satisfying. But yeah, I mean, I got it. I won't say good game, but I got a game. Like, it did play. It did show some, like, you know, some signs of life, which the Alpha Zero does not show yet, unfortunately. So yeah, I think that's actually pretty satisfying. Like, seeing just Alpha Beta, like, this detour is pretty nice. And then next stream, we'll just, like, build a UI where, like for example, if you go to BumperCoins, you look at, like, let's say map editor. Like, you see how, like, we have, like, some, like, kind of options here and stuff, like that. Like we have some panel here on the side. Like we have like the game like right here. Then we have like a panel here. Whereas like in like Connect 4 we have like all these options. Where like we have like the number of like we can like specify how much depth we want the bot to use or whatever, and so forth. Then like yeah. Like we have like a panel here, like some stuff in the bottom. Like the idea is to like let them configure which bot they want to use and like how many like the feature weights or like number of MCTS iteration simulations if it's using Alpha 0. So yeah, it's like give them the choice to like design their own game. Cause like if they're on a phone or something in for Alpha Beta, instead of depth 3, they might want to choose depth 2 or something because they don't have enough resources. It'll be too laggy. So yeah, that's like next stream, just cosmetic. Let's build a UI for this, like user configuration, player configurations. But yeah, I think Alpha Beta is basically done now. Like we got the features, they seem to work. So yeah, I'll just end it right here then. Yep.